Today we're going to be covering chapter 4 from our math analysis book, 4.4, trig functions of any angle. I sent you guys on Google Classroom a set of notes that you can do it on your phone or on a tablet, or you can print out and fill in, or you can do it on a separate sheet of paper. So again, if you look at your Google Classroom, you have notes titled 4.4 trig functions of any angle. If you want to get that out on your phone or on your tablet so you can do it along with me, or if you printed it out, or if you want to do it on a separate piece of paper. So as you look at this worksheet with our notes on it, 4.4 trigonometric functions of any angle, it's really what we have already talked about, but now our radius is not necessarily 1 like on a unit circle. So when our radius is not 1, my sine is not going to be just y. My cosine is not going to be just x. The reason that these were y and x was because, let me just kind of do a little sketch here. I'll do it over here on the side. Was because when I'm on a unit circle, let me actually, give me one sec to get this up. So if I'm on a unit circle of radius 1, okay, and so this right here, this distance is 1. If I was just to draw this out, let me use a different color here. So if I was to draw from here, if this is a radius of 1, then when I'm trying to find all my angles, okay, this particular coordinate would be, let's say, some x comma y. And so this distance here is my y. This distance here is my x. And then I'm trying to find this angle here at theta. Let me just write my theta in. I'll use black. Okay, so there's my theta. I'll make it a little thinner. Okay. So when I did it on a unit circle, my sine is opposite over hypotenuse, which is y over 1, but y over 1 is just y. That's why our sine became y. Now what's going to happen is our radius is going to be r, not 1. So it's still opposite over hypotenuse, but now it's going to be y over r. My cosine is still opposite over adjacent, but it's, opposite adjacent over hypotenuse, but instead of that being x over 1, which is x, it's now going to be x over r. Now our tangent, no matter what this radius is still opposite over adjacent, which is still going to be our y over x. So that's the change here, okay? So when you see these coordinates, if it's on a unit circle, then this is your sine and this is your cosine and this is your sine. But if this is not on a unit circle and you just have coordinates, don't take the x to necessarily be your cosine. It's going to be your adjacent over your radius, okay? X over r, and your sine is going to be y over r. So all of these over here are with us dealing with a radius of r. So if I'm going to zoom in for a sec, just for this picture. Let me focus it. Okay, sorry, the picture is a little blurry just in general on it. And so if I'm drawing straight down, okay, to my x-axis, this distance here is x, this distance here is y. So if this is our theta and this is my r here, then my sine is going to be opposite over a hypotenuse, which is y over r. My cosine is going to be adjacent over hypotenuse, which is x over r. My tangent is y over x. So that's where all of these values came from, okay? Now remember that we have reciprocal functions to these. And remember, I always say S doesn't go with S and C doesn't go with C. So since sine starts with an S, its reciprocal is not the one with S, it goes with cosecant. And so you see that's y over r. And then these, so that's r over x. And so cosine with secant, and then tangent with cotangent. Now, what some of us are doing when we're working this out is you're taking this fraction and going 1 over that fraction, and then leaving it kind of as a mess over here on this side. If you're given a fraction, flip the fraction. Okay, so if this is y over r, flip it. It's actually a reciprocal r over y. Okay, cosine is x over r, then the secant is r over x. Tangent is y over x, then our cotangent is x over y. And the way we would find our r is just using Pythagorean theorem. X squared plus y squared equals r squared. Okay. Now let's move to trying a problem here. Okay. So in this case, they want us to plot the point -2, 3 and have that be the terminal side of an angle. Okay. Find the sine, cosine, and the tangent of that. So what I'm going to do is I'm going to plot -2, 3. So I'm going to come to my graph and plot -2, 3, -2, 1, 2, 3. I'm going to put that point there. And again, I'm just going to label it -2, 3. And we're going to draw a triangle. You know, I'm drawing it to my origin like always. And then I'm going to draw it straight down and across. Now, when we're doing this, okay, I am in quadrant 2. So yes, this is a distance of 2, but I need to think about what direction I'm going. This is going to be a -2, okay? And this is going to be a +3 because I'm going up 3, okay? That's why this is a -2 and that's a +3. Now, your legs are always going to have your positive or negative signs. Your hypotenuse or your radius is always going to be a positive, because to find this, I'm going to use Pythagorean theorem. So I'm going to do 3 squared plus -2 squared equals our radius squared. Okay, so I'm going to get 9 plus 4 or 13 equals r squared. So the square root of 13 is r. So this radius here, this hypotenuse, let me draw my right angle, is radical 13. Okay, so it is radical 13. So now when I'm trying to find my angle, well, not my angle, but trying to figure out my sine, cosine, tangent, and so forth of my angle theta, let me just write theta in here. Okay, so this would be my angle theta. I am going to think opposite. This is opposite, this is adjacent, this is hypotenuse. So now let's see which ones they wanted us to find. So they want us to find sine of theta. Okay, so for sine of theta, so sine of theta, it is going to equal opposite over hypotenuse. So that's going to be 3 over root 13, which is going to, once we rationalize, be 3 root 13 over 13. So you want to rationalize these, okay? Make this a little fatter. Okay, so now cosine theta is adjacent over hypotenuse, and it's a -2 because I'm going in the negative direction. Root 13 over, sorry, -2 over root 13, which is going to be a -2 root 13 over 13. Then I'm going to do the tangent, okay? Now for the tangent, I'm going to write it over here. I would not, it is sine over cosine, okay? But I would not take this over this, because if you look at your picture, it's also opposite over adjacent, and that's just a -3 over 2. Now, if I was to take my sine over my cosine and simplify it, I would get this, but it would take a lot of effort, okay? So now we're going to be plotting these points. It's not a unit circle because this is not a distance of 1. So when I do opposite over hypotenuse, for example, I'm not going to be getting this 3 as my sine, okay? It's 3 over root 13, so we have to be careful with that. Now, down here, what this is showing us is basically what we kind of discussed the other day, just kind of writing it out. And so in each quadrant, it's kind of letting us know the coordinates of our x and y. Okay, so our x is positive or y is positive because everything in this quadrant is going to be positive, comma, positive. When I'm over here in this quadrant, my x is going to be negative, but my y is going to be positive. So again, negative x, positive y. Here, this is going to be negative, comma, negative. So you see negative, comma, negative. And over here, it's going to be a positive x and a negative y. Positive x, negative y. Now, you'll notice that they have these lines here showing this to this. So what's happening here is you'll notice in quadrant 1 and quadrant 3, your sine and cosine, or your x or your y, I should say, in this case, okay, your x and your y are both the same sign. So what that means is in these quadrants, your tangent, because it is y over x, are going to be positive. But in these two, when I draw this from here to here, these ones, you're going to have a negative tangent because when I'm taking my x over y, I'm going to have a positive over negative, which is a negative, or a negative over positive, which is a negative. So this green one is going to be tan equals negative, and the blue one is tan equal positive. Okay, so again, it's in opposite quadrants. Now over here, this is just really saying more of the same thing, okay? So so even if it's not a unit circle and it's not the actual x and y that are your sine and cosine, remember your hypotenuse is always going to be positive. So here it's showing you that your sine, cosine, and tangent are all positive in quadrant 1. Your sine is positive, your cosine's negative, okay, and your tangent's negative. Here your sine is negative, your cosine's negative, but your tangent's positive. Okay, again, because you have same signs for your sine and cosine. And over here, your sine is negative, but your cosine's positive. So again, in these quadrants, your tangent is going to be negative, okay? Okay, so now this next page is really just the same as what I just had on the last one, but it has all 6 of them. Now, really, you do not need to memorize all this because whatever sign, and when I say sign, I mean S-I-G-N-E, like positive or negative, whatever sign your sign is, so is its reciprocal, which is the cosecant. So your sine and cosecant are always going to have the same sign in the same quadrant. Whatever sign your cosine is, so is your secant. Okay, again, your sine and your cosecant is 1 over sine. Your cosine and your secant is 1 over cosecant. I mean, 1 over cosine. And then our tangent and our cotangent, since those are reciprocals, they're going to have the same sign. And that's the same in each of these quadrants. Okay, so this is just listing all 6 of them. But again, I would just, as long as you know your sine, cosine, and your tangent, I think you're good to go. So we're going to look at this problem here. I'm actually going to change this problem up because we actually did this problem the other day. I gave you guys a couple of them from this section. So let's change this up. Okay, I'm going to change the wording. So what I'm going to do is I'm actually going to take from my pens the white, and you can get to it if you click the little arrow, you get more color options. So I chose white. I'm going to use it kind of almost as whiteout. So I'm going to change this, and I'm going to change this, okay, since we did that problem the other day. And I'm going to get my black now. So I'm going to change this to, why don't we change this to secant theta. And this one will be tangent theta. Okay, so let's change it to those. And what we want to figure out is what quadrant is theta if your secant for that angle is positive and your tangent is negative. So first off, it's helpful to kind of think about secant. And your secant is, remember, s doesn't go with s, so this is going to be cosine theta. So I really want to know, hold on, sorry, really want to know where is my cosine theta positive, okay? Where is cosine positive? So the quadrants that cosine's positive, let me shade it in yellow, okay? So I'm trying to figure out where those are positive. My cosine is positive in these two quadrants. Okay, that's where my cosine's positive. So that means my secant is also positive in these two quadrants. Then I want to decide where my tangent is negative, okay? For this one, I'm actually going to use some stripes, okay? I'm going to use purple stripes. So I know that in these two quadrants, my sine and cosine are both positive here, both negative here. So in these two quadrants, my tangent is positive. In these two quadrants, my tangent is negative. So I'm going to shade those. So now you see this is where my cosine is positive. This is where my tangent is negative. So my answer is going to be quadrant 4. That is my answer, quadrant 4. Okay, I like to do the shading. I think it helps me focus where I am. Okay. Now on this next one, let's switch this up also. Now I'm going to switch it up slightly because we actually did do this the other day. So let me again adjust this. So again, I got my white and I'm going to change this, and let's say I change this to a -3/5. Okay, let's change that to a -3/5. Okay, since we did 4/5 the other day. And instead of this tangent being negative, why don't we change it to being positive? And then we want the cosine and the cosecant of this, okay? So again, let's look at my sine. Where is my sine negative? Let me just kind of jot that down. Sine equal negative, because my sine is negative. It's a -3/5, okay? So where's my sine negative? Well, my sine is negative in these two quadrants, in 3 and 4. So my answer is, my angles are either going to be in one or the other of these. Now I know my tangent is going to be positive. So where's my tangent positive? Well, my tangent's positive where my sine and cosine both have the same sign. So that's going to be in this quadrant here, and it's going to be in this quadrant here. So I'm down here in quadrant 3. That's where I'm going to be. So now I need to draw my picture, okay? So let me just kind of zoom in here. Let's say I get red. So I'm going to draw my triangle -3, 5. So I am going to start at my origin. Okay, and here's my triangle. And this is going to be theta right here. Okay, that's my theta. So when I'm doing this, and I know that my, so I was trying to change colors here. And I know where that my sine is -3/5. Remember, sine is opposite over hypotenuse. Now, your hypotenuse will never be the negative. And you'll notice that I am going down. So my sine, my y, is going to be negative. My opposite is going to be negative. So this is going to be a -3, and this is going to be a 5. And so now I got this right triangle. This is going to be a 3, 4, 5. But it's a -3 because I'm down here in this quadrant 3. And then my x is going to be negative because I'm coming this direction in my negative x side. So that's going to be a -4. And these are my sides. So now when they want me to find cosine theta is going to be adjacent over hypotenuse, which is a negative 4 over 5. And cosecant theta, well, that's kind of easy to do because it's the reciprocal of my sine. So that's going to be a negative 5/3, and that's my answer. Okay, so again, when you're doing this, I like to focus on the sign. When I say sign, I mean S-I-G-N, okay, positive, negative. Where is my sign negative in this case? I focus. Then where is this satisfied, which is in these two quadrants? So that puts me here. And then that helps me determine the signs of my X and my Y. Okay, so next one. So this one, we're going to actually be plotting a line. And we want it in quadrant 4. And it's going to be forming like my radius that I would be drawing, okay, or my hypotenuse. So this is the terminal side of theta lies on the given line in the specified quadrant. Find the values of the 6 trigonometric functions of theta by finding a point on the line. Okay, so first off, I'm going to get this into y equal form. Let me just kind of focus, zoom in. So this is going to be 3y equals negative 4x. So I'm going to get y equals a negative 4/3 x. So that's going to be the line I'm going to be plotting. So I'm going to start at 0, 0. Okay, that's going to be my y-intercept. And then my slope is a negative 4/3. So I'm going to go 1, 2, 3, 4, 1, 2, 3. And I can keep going, but that's good enough. I need to draw a line. They want it in quadrant 4, so I could draw it this direction, but I'm really focused on quadrant 4. And they want us to find it on any point. It doesn't matter what point on this line, so I'm just going to use this point. So let me just draw my line. Okay. And again, I'm at 0, 0, and then I'm down here. And so here, again, I went down 1, 2, 3, 4 over 1, 2, 3. So if I draw my triangle, this is positive 3, this is negative 4, and again, this is a 3, 4, 5 right triangle, okay? And again, let me just draw in my theta so we see theta, that's where theta is. So now I want to find, and I can find, even though I did not know the angle value, all I knew is this line, I now know all the sides of this triangle and I can answer. So sine is opposite over adjacent, opposite over hypotenuse, which is negative 4 over 5. Cosine is adjacent over hypotenuse, which is 3 over 5. Tangent is opposite over adjacent, which is a negative 4 over 3. Now, if I know these three, these are the reciprocals, okay? So let me just get a different color here. Your sine and your cosecant are reciprocals. Your cosine and your secant are reciprocals. Your tangent and your cotangent are reciprocals. So I'm literally going to flip this. Again, do not put 1 over this fraction. And some of us are doing that and leaving that as your answer. We want it in a simplified form. We don't like fractions and fractions, and we don't like decimals and fractions, and we don't like radicals in the denominator. Those are all things we need to change. So this answer, I'm going to flip this. I get a negative 5 over 4. This one I flip, I get a 5 over 3. This one I flip, and I get a negative 3 over 4. And those are the 6 trig functions for this angle theta. Okay, so let's look at the next page. So on the next page, this is dealing with reference angles, and we've dealt with reference angles before, okay? And your reference angle is always in quadrant 1, okay? So we're always thinking about quadrant 1. And so what it really is the distance that we're going from basically from your angle to the x-axis, okay? That is going to always be our reference angle. So over here, even though it's in this quadrant, I want to know how far off am I from 180, or how far off am I from pi, depending if it's in degrees or radians. So that's why here I took 180 minus it. okay? Or pi minus it to figure out how far off I am. Over here, when I'm in this quadrant, again, how far beyond 180 did I go? Well, I'm going to take this angle minus 180, or I'm going to take this angle minus pi. How far am I off? Similar idea over here, okay? How far am I from my x-axis? So if this is 360, take 360 minus this angle, and that's going to be this distance. Or take 2 pi minus this angle, and that's going to be this distance. So it's always the distance from that terminal end side to your x-axis. That's your reference angles. So if I'm looking at these problems, okay, and I drew these just so we kind of figure out where we are. And you want to pay attention to where we are. So, I mean, in terms of, I shouldn't say where we are, I mean, if it's degrees or radians. So this is degrees. So let me kind of zoom in on this particular one, okay? So if this is degrees, I'm really focusing on this being 180 degrees. Over here is 360 degrees, okay? So that's 180, this is 270. So I'm in this quadrant, okay? I'm just gonna sketch it. I don't need to be perfect with it. So let me make it a little thicker. So this is my angle somewhere in here, okay? I'm not being accurate, but I wanna be accurate at least with the quadrant, okay? And so I'm going this distance. Well, what I want is how far off am I, make it a little thinner. How far off am I from here? How far is this in purple? How far off was I? So if this is over here at 213 degrees, and this is 180, what I'm going to do, let me zoom out for a sec, is I'm going to take 213 minus 180 to get that angle. And when I do that, I get 33 degrees. So that is my reference angle, 33 degrees, because that's the distance from here to the x-axis. Okay, that's what a reference angle is. So on my next problem, it says 1.7. This is in radians, okay? This is in radians because it doesn't have a degree symbol, okay? So I'm going to be thinking about pi and 2 pi like that. So let me zoom in for a sec on this one. Okay. So again, this is 1.7. So this is pi, and pi is 3.14. And if I was to take half of pi, okay, literally I'm going to take pi and I'm going to divide it by 2. I end up with 1.57. So up here would be 1.57 radians. And again, this is pi, or 3.14. So my 1.7 is going to be sorry, I didn't want to get yellow, sorry, is going to be in between, so I'll try and get a little thicker, in between these two, closer to this one, but in between those. Let's say it's here. Okay, again, that's where I'm going. I'm going from here to here. That's kind of a fat one. Make it a little thinner. Okay, now what do I want? Well, I want how far off am I from the x-axis? How far away am I from pi? So if this is 1.7, that's where I am. How far off from pi? So the math I'm going to do is I'm going to take pi and subtract 1.7 to see how far off I am. Okay, so I'm going to take pi and I'm going to subtract 1.7, and I end up with about a 1.44. So this is 1.44 radians. That is my reference angle. Now, the next one is degrees. Okay, so again, I'm going to be thinking about 180 degrees. So this is 180 80 degrees. Up here is 90 degrees. So I'm going to be somewhere in between these two. Okay. So let's say I'm about here. And again, I'm going this direction. But what do I care about? I care about the distance to here. That's what I care about. I care about that distance. How far away am I? So again, if this is at 144, let me just kind of write it here real quick. Not yellow. 144. This is in 140 at 144. Okay, 144 degrees. How far off am I? So this time I'm going to take 180, which would be all the way to here, and take off my 144 because I'm short by so much. So if I take 180 minus 144, I end up getting 36 degrees, and that is my reference angle. Okay, so again, you always want to figure out how far above or how far below, how far off are you from your x-axis. And you either going to be paying attention to 180s and 360s, or you're going to be paying attention to pi's and 2 pi's, okay? That's what you're always going to be comparing it to, either subtracting or adding it depending on which direction you're going, okay? So in the next one, what we're going to be doing is we're just going to be evaluating these, okay? Now, when I ask you to evaluate them, I actually want you to, I'm not going to make you for these draw the angle in. I do want us to put the point in the right spot and give me the coordinates, okay? Or maybe you can draw, I would probably draw like the terminal angle. So let me just focus in on this one. So if I'm dealing with 5 pi thirds, okay? 5 pi thirds. So just a little reminder, this is pi, but this would be 3 pi thirds over here. And the other side, if that's 3 pi thirds, would be 6 pi thirds. And I want 5 pi thirds. This is 5 pi thirds. That's where I am, right there. So what are the coordinates of that point? Well, that point is short, comma, long. And every time I say short, I mean 1/2. And every time I say long, I mean √3/2. Now, in this case, it's going down, so it's a negative √3/2. So now sine, okay, this is a unit circle. And so sine of this is going to be my y coordinate. So my answer, okay, my answer is not the coordinates, it's the actual value, negative √3/2. And you should be giving me an exact value. Should not be putting it in a calculator. If it asks for exact, it means not a decimal. Okay, so this one here, cosine, let me just get a different color, okay? Cosine of negative 60 degrees. So I'm going this direction. I actually end up at the same point, okay? I'm just coming this direction. So I end up here again. So again, that's a 1/2 comma negative √3/2. And this time I want the cosine, and cosine is the x. So my answer is going to be 1/2. That is my answer. But again, I want to see this work here. Now, tangent of 11 pi 6. Okay, so if I'm doing 11 pi 6, I'm just going to zoom in here for a sec. This is pi, which would be 6 pi 6. And going all the way around the unit circle, this would be 12 pi 6. So this point right here, that would be our 11 pi 6, okay? Let me draw it so it actually touches that point. Zoom in a little bit. This is going to touch here and go here. And so this is going to be long, comma, short. So long is √3/2, and my short is going to be negative 1/2. And that's going to be the coordinates of my 11 pi 6. Now, I want tangent. Tangent is y over x. So when I do y over x, I'm going to have negative 1/2 over 3/2. Do not leave it in this form. Okay, we need to clean it up. So that's going to be, let me just make it a little bit smaller. That's going to be, basically, I'm taking this fraction divided by this fraction. So -1/2 divided by a √3/2, you can change it to a -1/2 times the reciprocal of what we're dividing by, okay? And so what happens is my 2's cancel out, and I end up with a -1 over √3, and then we're gonna rationalize that. So I'm gonna multiply top and bottom by √3, and so when I do that, I end up with a -√3 over 3. And that's going to be my answer. That's going to be my tangent, okay? So let me just put it up here real quick. So this is going to be a -√3 over 3. Okay, and again, you need to rationalize, and you need to make sure you don't give me fractions and fractions, okay? Okay, so now, next one down here, okay? So we know that the angle's in quadrant 3 because they told us. So I'm going to actually highlight quadrant 3 to focus myself. This is where I am right here. I'm over here in this quadrant. That's where I am. Because if my sign's negative, my sign would be negative in this quadrant and my sign would be negative in this quadrant. It'd be negative in both, but I'm here because they're telling me I'm here. So now let me just draw this out. Okay. So I'm just going to draw a triangle. I don't really care where I'm drawing it to. I'm not going to be accurate with that. But what I need to be accurate with is sine is, and let me just put my theta in here so we know where I am. That's my theta. Okay. So sine is opposite over hypotenuse. Again, the hypotenuse is always going to be positive. So this is going to be positive 13. This is going to be my -5, which you see it should be because I'm going down. And then we're going to do Pythagorean to find this, okay? -5 squared plus x squared equals 13 squared. But a lot of us might recognize this as a 5, 12, 13 right triangle. Now, it's not going to be a positive 12 because I'm going this direction. It's actually going to be a -12. So now when I find secant, and it's secant, remember, S doesn't go with S. So this is really 1 over cosine theta, okay? So let me just write my cosine theta real fast up here, cosine theta. You're not asking me for it, but it's helpful to me. So cosine would be adjacent over hypotenuse, adjacent over hypotenuse. So my secant is the reciprocal of that. So don't go 1 over this fraction, okay? It's the reciprocal of this, which is a -13 over 12, and that's your secant. Now my tangent, again, I would focus on it in terms of opposite over adjacent, -5 over -12, so that's actually going to be a positive 5/12, and that would be my tangent. Okay, so now let's go to the next page. So this next example, they want us to find 2 answers for theta in exact form, okay? And so we're trying to find the angle, and they want us to do it, give 2 answers in degrees. That's what this is telling us here. So let me just kind of highlight that. So this, when they say this, it means they want it in degrees. And then when they say this, they want it in, oops, didn't mean to cover it. They want it in radians, okay? So I'm going to do what I did before, okay? I am going to focus on where is my sign negative. So my sign is negative in these 2 quadrants down here. So this is where my angle is going to be. It's going to be one of these, one in this quadrant and one in this quadrant. So in 3 and 4. So my sign on a unit circle, where is my sign? -√3/2. So that is our long, okay? So I'm going to be going short, long. So one of them is going to be here, and then short, long. One of them is going to be here. And so I want to know where this is, okay? So again, let me just write the point here. I'll write it in here. So I have space outside. So this would be short, -1/2, comma, long, -√3 halves. And this point here is going to be short 1/2 and long -√3 halves. So that's why these 2 points have this as their sign. So where am I? Okay, well, if I'm doing it in degrees, okay, this is going to be 200, whoops, fat pen, I'm choosing all my fat pens today, 240 degrees. So 240 degrees, because it's 60 beyond 180, and this is 60 short of 360, so this is 300. So those are 2 answers, 2 angles from 0 to 360 that have this as their sign. Then I also need to do 2 in radians, okay? So for radians, this is going to be a pi third. This would be 3 pi thirds, so this means this would be 4 pi thirds, and this would be 5 pi thirds. And so those are my 2 answers, 2 of them in degrees, 2 of them in radians, okay? So now we're going to do the same thing with this problem. Where is my cosine positive? So my cosine's positive in these 2 quadrants. So I'm going to be in these 2 quadrants. And then where is my cosine √2 halves? Well, it's going to be √2 halves here and here. Okay. So again, let me just write this out. This point right here, I'll write it this direction, is √2 halves, comma, √2 halves. That's where that point, the coordinates are. This one down here is positive √2 halves, negative √2 halves. So positive √2 halves, negative √2 halves, okay? And then where am I on the unit circle in terms of degrees? So in terms of degrees, okay, from 0 to here, this is 45 degrees. And here I'm 45 degrees short of 360, which is 315 degrees. And then I'm going to do the same, but in radians. So in radians, this 45 is pi force. And in radians, okay, I'm 1/4 off of this. So all the way would be 4 pi force. All the way back to here would be 8 pi force. So this is 7 pi force. So again, I have 2 answers in degrees, and then I also have the 2 answers in radians. And both of these would give me this as my cosine, and same with the green ones. Okay, so now let's take a look down here. This is a similar idea, but now we have them not in a nice unit circle form, okay? This isn't one I would identify. So here we're going to get 2 answers, and this time we want it in just degrees. Over here, we want our 2 answers in radians. So where is my cosine negative? My cosine is negative in these 2 quadrants. So this is where I'm focused, okay? Now, the way I like to do it is I actually like to just figure out where would it be just in quadrant 1, okay? It's kind of nice to know like the reference angle. Okay, so what I'm going to do is I am going to figure out the cosine inverse, and here, let me do it down here, give myself some space, okay? So I'm going to do cosine inverse, I'll do it here at the bottom, cosine inverse of, and I'm just going to do the positive 0.5736, because that would tell me where it is here, and then wherever it is here in this quadrant, that's how far above and how far below 180 I need to go. So I need to make sure my calculator is in degrees, okay? So let me get my calculator in degrees. And then I want cosine inverse. I want to know what angle gives me that. So I'm going to do second cosine, cosine inverse, and I'm going to type in positive 0.5736. So I like, again, I like to do the positive so I know where it is in quadrant 1. So it's about 55 degrees. Let's round that up to 55 degrees. So this would be 55 degrees, okay? Now, that's not going to be my answer because that would be in this quadrant. But what I know is that I'm going to be going 55 degrees short here and 55 degrees more here. So this is 180, okay? So to get this answer, I'm going to be taking 180 minus 55, okay? So let me just write that here. I'm going to take 180. I'm going to move this around here. Okay, so I'm going to take 180 minus 55 to get this answer. And for this one down here, let me spin it around for a second. I'll put it back. This is going to be 180 plus 55, okay? So again, it was about 55 degrees. So the one here is going to be 180 minus 55, and this one's going to be 180 plus 55. Okay. So if I do 180 minus 55, I get 125. And if I do 180 plus 55, I get 235. Okay, so one of them is going to be 135 degrees. The other one, and maybe I should flip this and write it the other way. Let me do that. Okay, so 180 minus 55 is 125, and then 180 plus 55 is 235. And those would be my two answers, okay? I'll highlight it in color. So that is one of the angles, and that is your other angle. So for this one, I'm going to do the same thing, but this time they want it in radians, okay? So again, I'm going to do sine inverse, and I'm going to do it at a positive 0.6428, so I can figure out where I am here. Now, sine is supposed to be negative, so I'm not going to be in that quadrant. I'm going to be in these quadrants. But again, I always like to find my reference angle, and then I can figure out how far below and below I'm going, okay? So again, I'm going to do sine inverse of a positive 0.6428. And I want to make sure my calculator is in radians this time. So I'm going to change it to radians, okay? And so I'm going to do sine inverse of 0.6428. And I end up with, let's say, 0.70, the 698, let's say it's about a 0.70, okay? So this would equal 0.70 radians, okay? So what that means is I'm gonna be 0.70 beyond pi and 0.70 short of 2 pi, okay? So let me write those real quick. So again, I'm going to go 0.70 beyond pi, and here I am 0.70 short of 2 pi, okay? So I'm going to do pi plus 0.70, which gives me about a 3.84, and then 2 pi minus 0.70, which gives me a 5.58, okay? So again, pi plus 0.70, I put in my calculator, got a 3.84. 2 pi minus 0.70, I get a 5.58. And those will be my two angle values in radians. So again, I figure out where my sine is negative or my cosine, whatever sine I'm dealing with. I then find the inverse of this, And I always do the positive, so I always know where it is in this quadrant. And so I'm always focusing on how far above or below 180 or pi, and how far above or below I am of this 2 pi. And that's our notes.